Properly using database structures enables us to store and organize data so that we can easily use and find it. Instead of having simple spreadsheets like Excel or Google Sheets, our databases use connected tables to manage large amounts of data in order to use that data effectively. Let's talk about the types of databases and data structures that you need to know. First, we'll be talking about relational databases, non-relational databases, flat file and proper databases, and then we'll be discussing structured and unstructured data. Let's talk about the types of databases and data structures that you need to be aware of. First, in terms of databases, we're going to be covering relational databases, non-relational databases, flat file and proper databases, and then in terms of data structures, we're going to be talking about structured and unstructured data. With structured and unstructured databases, structured data is any data that's organized in a specific and fixed format, like in rows and columns. Unstructured data, on the other hand, is data that can't follow a specific format of structure. This includes things like text files, images, videos, and emails. Normally, when we work with databases, we build data into structured data. Even if we have unstructured data, we need a way of converting that unstructured data into structured data. And there's a wide variety of ways that we can do that, especially with ChatGPT. Nowadays, you could take a screenshot of, say, an image, and then ChatGPT could actually structure that into usable data. In terms of structured data, again, data is organized in rows and columns within databases and spreadsheets. It's easy to organize and search, and it's most commonly used in business systems, productivity tools like Google Sheets and Excel. And unstructured data, on the other hand, is data with no fixed format. Again, that's photos and videos, harder to organize and search with, and it's common in media and everyday files. Let's get into databases now, starting with relational databases. These databases store our data in more organized tables. It helps us keep our data accurate, easy to find, and organized for simple use. Relational databases also store data in simple tables. They make finding and updating things easy, and they overall help keep our data accurate and consistent. Here's an example of a relational database for a course company. They might have a table with students and student courses and courses. All of this data is neatly organized. And you can see here, this would be a good example of a relational database. Next up is non-relational databases. These are most often known as NoSQL databases, and they're essentially databases that store data and information that doesn't fit neatly into rows and columns. Common types include document databases, which store data on documents, and key value databases, which store data as pairs where a unique key is linked to a value. In terms of non-relational databases, we have document databases and key value databases. Again, our document databases store data in documents. They're usually flexible. They allow searching through stored data. And an example of them is a user profile with name, email, and settings. Key value databases, on the other hand, store data as a key paired with a value. They're rather simple, and data can only be found using the unique key. An example here would be a user ID being linked to stored data in that actual database. Here's another look at relational versus NoSQL databases or non-relational databases. So in relational databases, we have tables and rows structured very specifically, and we can also use generally SQL queries in these relational databases. Most of the time, keep in mind, relational databases use SQL. Non-relational databases often don't use SQL, and that's why non-relational databases are often called NoSQL databases, like they are here. Just keep in mind, this is relational databases or SQL databases. This is non-relational databases or NoSQL databases. NoSQL or non-relational allow for documents to store data, and they usually use key values. They generally have very flexible data and data types, and they often have a high speed just because they're rather simple. Next up is flat file and proper databases. So first off, a flat file database stores data in a simple table with rows and columns, quite structured, and then a proper database organizes data into multiple related tables, making it easier to manage large amounts of information and also connect that data. Let's first go into the flat file database examples here. So flat file is more structured, has a single table with rows and columns, cannot easily link related data just because it's one table, and it's rather simple and limited and harder to manage as you get a lot of data. A proper database, on the other hand, generally can use multiple tables linked together. It can also connect related data using keys, and they're often organized as well as scalable. Lastly, they're easier to manage and update for massive amounts of information. Now, for smaller amounts of information, a proper database might be a little bit more strenuous and a little bit harder to manage than a flat file. But if we're talking about data from a high level perspective and mass amounts of data and information, generally a proper database is more simple to manage and update in the long run. But flat file, remember, they're a little bit more simple for lower needs or for lower amounts of data. And those are our data types and database structures. You don't need to know these super in depth for the exam. Just understand what each database does, what its use cases for, and why they exist.